Water flows from a cylindrical tank with a cross-sectional area of 50 feet squared through a hole quarter feet squared, 1/4 foot squared, feet squared, quarter feet. I think only one is singular. I think less than one is still plural. I should look that up. At the bottom of the tank, given that the height of water in the tank is initially 20 feet, okay, above the hole, so h is 20 initially, okay, and above the hole and h of t with t in seconds as initial is given by, okay. So they give us all this information, and they're like, magic formula. And so, okay, so we can probably pretty much ignore this whole first part because they're just like, we used this to get you this equation. It's like, okay, I believe them. Find the rate of change of the height of water above the hole when the height of the water is 9 feet. So we have a rate of change of height of water. Okay, so we know the equation for height of water. So when we take the derivative with respect to time, we will find the rate of change of h of t with respect to time. So I'm going to rewrite h of t because I just don't like square root symbols. Nothing against them, they're probably fine people, but it just helps me focus on what's important when they're written as exponents. H prime of t equals, okay, so now we're doing derivatives, so exponents get lower. So 2 times 1/2 times h to the negative 1/2 plus 1 over 25, and then the t just goes away, and the constant also goes away. So rewriting this one more time, I guess I could rewrite it a couple more times, but one should be sufficient. H of t equals 1 over square root of h plus 1 over 25. Is this all we need? Maybe. Find the rate of change of height of water. Okay, this is the rate of change of height of water when h equals 9. Okay. This isn't too bad at all. We got this. Go team. Go team. So they said that this value equals 9. Find that value. So, wait a second. Did we just get rid of t? Why is there no t? Interesting. Wait a second. Did I miss something? I think I did. Okay. So here we have h, and here we have t, but I treated this h just as h. I don't think I should have done that. I think that was taboo and bad. So I'm going to move this over. So this is actually, I should have used the chain rule here. So I'm going to look at this over here. 2 times h to the 1/2. I'm going to say h of t to the 1/2. This is actually going to be implicit differentiation here. So when we take the derivative of this with respect to t, that's a symbol for a partial derivative. It's just saying we're taking this derivative only with respect to t. Everything else is kind of assumed to be constant. I'm just saying take the derivative with respect to t. That's a 2, that's a delta. I know, my handwriting is atrocious and terrible for math. Okay, so when we take the derivative of this, as I said, h of t to the negative 1/2, but then we also have to take the derivative of the interior. The interior here is h of t, so we get a dh dt here as well. So I should have had another dh dt right there. So that's going to make it a little bit more challenging. Well, maybe not challenging, but exciting. It'll add some excitement to our otherwise dreary existence. So that's just 1. And so I'm going to rewrite this as dh dt. I'm going to move this over to this side. So we have dh dt minus 1 over square root of h dh dt equals 1 over 25. Okay? And factor out a dh dt. We have 1 minus 1 over square root of h equals 1 over 25. And we have dh dt equals 1 over 25 divided by 1 minus 1 over square root of h. Square root of h. Okay, we got this. We got this. Go team. Go team. Focus. Okay. So now dh dt when h equals 9 equals 1 over 25 all over 1 minus 1 over square root of 9, which is 1 minus 1/3. I'll rewrite this as 3 over 3. This is 1 over 25 divided by 3/3 minus 1/3 is 2/3. And so we have 1 over 25 times 3/2, which gives us, did I forget it? 3/25. 3/50. Whoop, 3 over 50. This is the only one that looks similar. Maybe I missed it from somewhere. Normally I would second guess myself, but I'm pretty confident in what we did here. So for this one, I'm going to say the answer for this is wrong. And this should actually be 3 over 50. And so the answer will be 3 over 50 feet per second. All right, that's how you do this problem. The trick here is you have to look at this. You normally have the independent variable here. You know, if you have y's, you'd have x's. In this case, you would expect a t to be there. If there wasn't a t, there was an h. And so you have to do the implicit derivative, which will require the chain rule, then simplify and solve. That's how this problem is approached. See you on the next one.